Hello and welcome to Talk Julia. My name is David Amos.
And my name is Randy Davila.
So Randy, we talked about some fun stuff last week, but we kind of skipped over maybe talking more about like some beginner content, which we're still very much Julia beginners. I spent a little bit of time this week looking into how functions work in Julia and some more on this idea of multiple dispatch, which I think if you know, anytime you search for Julia, it's like one of the first things you learn about the language, or you start hearing about the language. So I kind of just wanted to do a run through of some interesting things that I found while I'm kind of learning about this, and some, my commentary on it again from a Python perspective. If you've ever written a function almost in any language before, I feel like you almost instinctively know how to write a function in Julia. It uses the function keyword instead of, say, like the def keyword in Python. And you have to end it with this end keyword instead of using like curly braces or something like that. But I think we talked about on I can't remember if it was the first or second episode, this, idea of returning a value without the return keyword.
Yeah, we mentioned that.
Yeah. So, that's something that looks odd to me. So I'm looking at a function that has two parameters, X and Y, and returns the sum of those, X plus Y, or whatever, the plus operator does to whatever the arguments are. But you don't have to, when you return the value, you just type X plus Y and that gets returned.
Yeah, it's the last line of the code block contained in the definition.
Now there is a return keyword, and, you can use it. So for example, why this using just, the last line in the function as a return value. If that's the only way to return a value, it would be difficult to say, stop the function, return some value based on a condition somewhere in it, right? So you've got this return keyword that'll let you do that. Anywhere that shows up is just going to return, so it's nested in like an if block or something like that. But I thought to myself, like, okay, there's two ways to do this. What's like the right way, right? Like, what is the idiomatic Julia way of returning a value from a function? And I thought, well, why not just go to the source, right? So I went to the Julia language GitHub repository and clicked into the standard library folder and just scrolled down and thought, okay, here's the dates module, right? Like what does it look like in there? And maybe we'll do the arithmetic, look at some of the arithmetic functions. And you scroll down and you see, okay, they're using the return function, or sorry, the return keyword in all of their function definitions here. Okay, what about something else, right? So I went back to the standard library and found what looked interesting to me, linear algebra. And what does it look like in there? How are they doing that? So I just picked a random one. I think it was bitarray.jl, and go through and in these functions in that module, they're not using the return keyword.
So this illustrates something that I've been thinking about. I feel like there needs to be like a document somewhere illustrating best practices when writing Julia code, right? This is somewhat easy to find in the Python community, but it seems to not have found a cohesive set of rules yet in Julia for what is the best way to write functions so that other Julia programmers will look at it and not have to like quickly decide or quickly decipher, what's happening.
So you're thinking of something kind of like the PEP 8.
Right. Like
Python.
what is the PEP 8 version for Julia?
So I think there is like a Julia language style guide. Yeah, I was gonna say, I remember seeing this. So this would be, I think, similar to like what you're looking for. And it's got like, what are the idiomatic ways of writing things, tips and tricks, things like, write functions, just not scripts, avoid writing overly specific types. And there's a whole bunch of stuff in here as well. So it's maybe not as opinionated, maybe that's the right word, than something like PEP 8 is, which PEP 8 has, for example, like preferences on how you should, put white space around operators when you're doing like math versus other things, or, there's all sorts of, I think, very specific things.
This document that you're looking at right now, this Julia docs, this like style guide, that guy from Julia for Talented Amateurs, I was watching one of his videos and he was saying that he was reading through this, but it wasn't as clear as he liked. So he had to go and he found some other source somewhere that had like these very specific like PEP 8 type of things for Julia. I don't know what document he was looking at, but I remember distinctly, since you just brought this up, that this is something that he mentioned.
Gotcha. Yeah. I mean, I would think, PEP8 is not a rule in Python. And if you're listening and don't know what PEP8 is, it's basically the style guide. It's kind of it was accepted as a, PEP stands for Python Enhancement Proposal. So it was accepted as one of these enhancement proposals. And it gives very specific instructions on how to write certain things in Python. But I think, PEP8 is not like hard rules about how to write Python. And it gets broken all the time by people who evangelize PEP8 as well. And I think, a lot of it comes down to, if you're working on a team somewhere at a company, whatever language you're using, there's probably, beyond just kind of an accepted general language style guide, there's probably a team specific style guide as well, about the ways that you would format certain things and things like that. So maybe, I don't know this history of the style guide in Julia, but maybe it's that they're trying not to be as opinionated with it. But going back real quick, just in the Julia language itself, in the standard library, you've got two different modules that are seemingly using two different styles of whether you should use the return statement or should not use the return statement, even if it's the very last line of code in a function. But as I scrolled down the document, looking at all the functions, so this is back in the bitarray.jl module in the linear algebra package, you keep scrolling down that module and all of a sudden you start seeing examples with the return the return statement. And I think it goes through the rest of the document there. And I'm not like taking a jab at the Julia developers or anything. You can find tons of examples like this in Python's implementation as well, like the CPython implementation.
Yeah, I don't think it's a jab. I just think that as we're learning Julia, we would like to follow the best practices. I like the return statement just because it's kind of it's explicit to me what's happening. It's breaking out from the function code block. It's breaking out. It's doing something, right?
Yeah, I'm the same. I think I'm going to stick to using the return statement. So anyway, I didn't mean to make such a big deal, I guess, out of just the return statement, return keyword there, but it's an interesting thing, right? And you think about, like, if you have a question about what's the idiomatic way to do this in a language, kind of a natural place to go would be to the things that are maintained by the core language developers and see what they're doing. So
back to functions and excluding how you return the values from the function, if the function is going to return anything at all, right? Mm-hmm. There are several ways of defining functions. And this is somewhat different than Python, right? Yeah. There are the code block styles with like function, give it a name, put your variables in there, code block, return something, end. But then there's also these anonymous functions, these one-liner functions with an arrow. And then there's also defining the function not as an anonymous function, but just defining a function in one line like you would see in a math textbook.
Right. Yeah. All those are mentioned here in the manual section on functions. So I scroll down to where it says anonymous functions. And yeah, to your point, so I think these work best for almost like mathematical type functions, really. But, if you can express it as like a very simple expression, then you can, do this to like X, and then I call it like goes to, right? But it's the dash and then the right caret, say something like X squared or something, the anonymous function. But to your point on, writing functions on a single line, not anonymous functions, but named functions, this was kind of an interesting thing as well, I think, coming from Python. Yeah, right at the beginning, when you first get introduced to, how to write a function, it says there's a second, more terse syntax for defining a function in Julia, where it almost looks like the function name and its parameter list are like a variable, and you're assigning it using the equals operator to some like expression here. So this one in particular we're looking at says f, and then in parentheses x comma y, close parentheses, is equal to x plus y. That's defining a function. Moreover, it says here that short, simple function definitions are common in Julia. The short function syntax is accordingly quite idiomatic, considerably reducing both typing and visual noise. So that's something I would say is definitely a kind of a change, coming to Python. I think that this sort of writing functions on a single line is considered idiomatic, because it is not in Python. This is considered, idiomatic Julia. And I like that.
So while we're looking at this one line function of f of x comma y equals to x plus y, all in one go, I'd like to talk about this plus operation in Julia with regards to multiple dispatch, which I know that you're going to talk about in a moment. I just was looking at that plus function and thought about what I was playing around with in a Pluto notebook earlier before we met up.
Nice, yeah.
So an interesting fact in Julia is that we can specify specific types for given methods, for example, addition. So on my screen right now, I have 3 different ways of adding 1, right? And the first way is 1 plus 1, where there's no decimal expansion. So these are integer values, right? And before the expression 1 plus 1, I'm using this at which macro. This macro in Julia, it's built in, will tell you what method is being used for that given operation. So for example, for these 2 integer values, 1 plus 1, I type at which before that, and it says that this plus operation is taking in 2 variables, x and y, of double colon capital T, where this capital T belongs somewhere in this list or this set of possible types, integer types in this case. They're all integer basic, int 16, int 32. But if I change it, so in the next cell of my Pluto notebook, I have 1.0 plus 1.0. So again, back to the plus stuff, and I'm calling the at which macro again. I run that cell, and I see that it's specific to float 64 for both of the entries. And on the line below that, I do the at which macro again, except for this time I'm doing 1 plus 1.0, just to kind of see what's happening. And in this case, the addition operation is happening on types of type number. So number is one of the built-in types in Julia.
Yeah.
Now, also, there's a built-in function called methods that will list out all the possible methods which depend on the types that are passed into the function, right? You can think of the addition operator as like a function, right? It takes a tuple of entries and returns either an error or some value, right? So it's almost like the addition is a function. So if we pass the plus sign into the methods function, we get a giant list of all of the ways in which this operation or this function is going to run in Julia, depending on the types that are put in, right?
Right. Yeah. I think, first of all, we should be clear what we mean by method here. We didn't really say exactly what that is, but I think we've kind of hinted at it. And that is, if you have a function that does something on some arguments that get passed to the function, you can change the behavior of the function based on the type of the arguments that get passed. If the types are integers, right, you could do something different. And you can define a function with the same name, but that has different types of arguments or even a different number of arguments, and it becomes what's called a method of that function.
On that note, we should probably mention that the method that is chosen, right, the act of choosing that method is called dispatch, right? And in Julia, you're allowed multiple dispatch, which you were just saying, like you can have the name of a function and the method choice will depend on the types that you pass into that function, right?
Yeah, all the types of every argument. That's kind of the important bit,
right? Yeah,
multiple dispatch.
In other languages, it's typically the first argument that you pass it. Whatever type that is going to determine the method that's used, right? But yeah, I guess I really interrupted you there. But what else do you?
No, it's all good. It's part of the conversation, I mean, I think we pretty much covered everything that I wanted to to talk about at this point. I mean, we'll talk more about this stuff in later episodes, but I do want to mention that there's a section in the manual, the Julia manual, on methods as well. It's quite extensive and has a lot more information than we've covered here. But there was one issue that that comes up with multiple dispatch that I wanted to make sure we mentioned while we're talking about this, and this is method ambiguities. And so I'm glad they included this. I mean, well, they have to in the manual. They really should, right? So I'm glad they did. But it also, it was like a kind of a burning question in my mind while I was reading this, and so it was nice to see this, then answered for me right there in the same document. But the idea is that if we can create methods on a function that take different combinations of types of arguments, then could you put yourself in a situation where you can't tell which method you're supposed to use given the arguments that you pass to a function? Like the dispatch system can't decide. There's like multiple candidates, and you can do that. So there's an example here of a function called G that takes 2 arguments. The first one, X, is specified to be a float 64 type, but the next one, Y, can be any type. There's no nothing is specified. And it returns 2X plus Y. And then there's a second method on that function G, where the first argument X now is unrestricted, like it doesn't have a type indicator on it, but the second argument Y must be a float 64 value. And it returns a totally different combination. It's X plus 2Y now instead of 2X plus Y. And so you can see, it gives an example of like calling it with the different types, where, you call it with a float in the first argument and an integer in the second argument, you get one value. And if you call it with an integer, like this, the same integer that you used in the first argument before as a float, but use it as an integer, and then, the same number you used as the integer in the first one, now use it as a float, then you get a different value. But what happens if you put both values, try to call G where both values are of type float? Well, what happens is you've got two methods where either one could be the right method, or the one, that matches the types of those, right? Because both of them have one parameter that's a float 64 and the other one can be anything. It's just the order that matters. But if both of them happen to be float 64s, you don't know which version of G to call. So what Julia does then is, what it should do is that it shouldn't pick anything for you. It should say, hey, we have a problem. And it does. It gives you a method error, and it tells you that, the way the combination of types that you used when you called that function is ambiguous. And it shows you that there's even like what the candidate methods are, and prints out like their signature for you to see. And even gives you a possible fix.
I love that. I love the possible fix.
Possible fix would be to define a method that specifies what to do precisely when both arguments are floats. So if you're designing a function that has a whole bunch of methods and is taking advantage of that multiple dispatch, you need to be careful of ensuring that none of this ambiguity can occur, so that your users don't find themselves in a position where they can't use the function the way they need to because the right method isn't implemented.
Yeah. So I want to continue this talk about functions because I feel like we're leaving something out. The ordering of the variables that go into the function, as well as keyword arguments, because it is different than in Python. I'm going to, in front of me, I'm going to say a function, maybe because I'm always plotting lines. I'll call this like a line function, and it takes in a slope, and it takes in a, I'll call it a bias. Thinking machine learning, I'll call it weight and bias. Actually, the first argument will be X, second argument is weight, third argument is bias. And inside the code block of the function definition called line, I'll say Y is equal to weight times X plus bias, just to be explicit, and then I'll return Y, and then end up that function call. So this function should work as you would think. So if I just do the line value at, I don't know, 10, and then have a weight of 1 and a bias of 1. If I call it, I get 11, as you would expect. Mm-hmm. But now suppose like you wanted to make this more customized, and you set your bias equal to 0. So going back into the cell where I'm defining my line, I have X, comma, weight, comma, and then I have bias equal to 0.
Yeah, providing a default value, right?
Right. So you would think that like maybe this is like a keyword argument. So if I now in the cell below call this function line with the parameters 10, 1, I'm not giving it a bias. It returns what you would expect. It sets the bias equal to 0 by default, and it returns 10. But now if I come in here and I do comma and I say I want to change my bias to be 1, right? Like I'm calling the line function 10, 1, bias equals 1. I'm trying to enforce the bias to be 1, I get an error. And that's because this is not a keyword like you would see in Python. So if I wanted to change the bias value, instead of saying bias equals to 1 when I call the function, I just put in a 1. Even though the third entry says bias equals 0, like it would be a keyword, it's not. it's in that third place. And if you want to change that third entry, you have to put a 1 in that third entry.
Yeah, I see what you're saying, because in Python, if you do that, like you have it written in this Julia function, in Python, that would automatically become like you could use that as a keyword argument.
Now, in Julia, you have to indicate that you are beginning to provide keyword arguments by putting a semicolon instead of a comma. So now in my function definition, I have line, open parentheses, x, comma, weight, semicolon, then bias equals to 0. Now I get an error when I try to run line 10, 1, 1, because this bias term is not the third entry. It's a keyword now. So if I want to change the bias, I have to now explicitly write it out or type it out, and then it'll work. This is kind of interesting in that anything that follows the semicolon will now be a keyword argument, and anything before it is an ordering of the variables that you put in, and you don't specify any keywords there.
So those are typically called positional.
Oh yeah, positional arguments. Yeah. But yeah, so that's kind of cool. That, or not cool, but it's just it's something to note if you're coming to Julia from Python, for example, which we will keep on saying over and over again because that's what we're doing right now. But when I was programming in Python primarily, still, I often would use Python classes. And Python classes contain data and functions in the form of attributes and methods. Julia doesn't have that. So I had to look around and figure out the best way to do this. For example, if I were to write a neural network from scratch in Julia, what would I do? And what I decided on was the composite type, because composite types are types like any other type in Julia, but they contain as many different fields or data as you want. And there are two different types. There are the struct type and the mutable struct. And the differences can be explained by their names. Structs, once you define them, are not mutable. So the fields of that instance are not mutable, whereas mutable structs are. So on my screen right now, I have struct single neuron. I press enter, go into the code block describing it. And then I have that this single neuron is going to have a weight of type float64 and a bias of type float64. Now, once I run that cell, I can make an instance of this single neuron. I can say something like node is equal to single neuron, and then open parentheses and pass in the correct order, the weight and bias. So suppose I want a weight of like just random weights, and then I'll just have a bias of like 1.0. And this now creates or instantiates a single neuron type. And I can access the fields of that type with the dot notation. So I can say like node was the variable I made, dot weight, and that will show me my current node weight. If I wanted to know the bias, I would say node dot bias, and that would give me my bias. So it acts like a container in a similar way to Python classes. It's not exact, right? There are these dunder methods and things like that, but it is something to work with. And if I were to do a actual single neuron for like the perceptron, this would most definitely be a mutable type, a mutable struct. That way I can update the weights over time and the bias over time, specify exactly what the types of the weights are and things like that. So just something that I think beginners should know about. And I think kind of ties in nicely with our discussion about functions, because you have
when you create like a struct, right, which is a composite type, then that can be used in a type declaration in like a on a function argument, right? So
right, exactly. And that's how you would do it. If you were to do like the perceptron update rule as a function, right, the input would be of type single neuron.
Right. Yeah. And you're right. I mean, there isn't really this, object-oriented paradigm at play here at all. And that can be a pretty dramatic change coming from Python, where it's like OOP all the way down, it feels like. The big difference being, right, your composite types, they only contain data, and then any behavior or something like that you would typically model with like a class has to be done using a function that you then pass the your whatever instance of your type to. So definitely can be that's like, it's kind of a weird shift. You still have this dot notation on these structs that makes them kind of feel like objects, right? Because you can access like their fields. And I think in my mind, it sort of becomes like, how do you encapsulate things then together? If you can't use a class, well, you use a module, right? So the module sort of becomes like the encapsulation of like, here are the different structs and stuff that I have, and like the behaviors that they need are defined as functions in the module. So more, differences between writing Python and writing Julia.
Right. Which I imagine we'll be doing for at least like half a year.
Probably. Yeah. Well, I think we've covered quite a bit of ground this episode. So I think we can call it a wrap there.
Yeah.
And
yeah.
well, thanks again for hanging out and talking about Julia with me.
And as always, I enjoy it.
Yeah, same here. All right, man. We'll look forward to seeing you next week.
Yeah. See y'all next week.
Bye.